Welcome back, friends. In today's class, we'll talk about the forces on an inclined plane. So let's start with an inclined plane. Let's say this is an inclined plane which is making an angle of theta with respect to the horizontal surface, and there is a mass m, there's a block of mass m placed on this surface. And I wanted to find out what are the different kind of forces which are acting on the surface, and we're gonna assume that it is not a frictionless surface, because we wanted to write one generalized equation, and then we're gonna try and use that equation to solve different problems. So this block is of mass m. Because of this mass m, the gravity is trying to take it straight in the downward direction. One of the concepts which you all try to remember always, that the gravity always acts straight in the downward direction. Now I wanted to resolve the components of this gravitational force, which is equal to mg. I wanted to resolve the component of this force along the inclined plane and perpendicular to the inclined plane. So how can I do that? So what I can do is, if I draw a line perpendicular to this inclined plane, this will be like this. Now if I try and draw the components of this mg force along the inclined plane, so along the inclined plane, this will be the component, and then perpendicular to the inclined plane, there will be a component like this. So I've broken down this mg into two components. Now one of the things also you need to remember is, if this angle is theta, we're gonna take this angle as theta, and I'll prove it in some other video also why this angle is theta. Just for the sake of this video, because we have a limited time, we're gonna tell you a shortcut that if whatever this angle is, that will be equal to this angle. So now what can I do? Because this component of the this component which I've shown it along the inclined plane, I can also show this vector here also. So remember the properties of the vector. So I'm going to talk briefly about the properties of the vector. If I wanted to show, let's say 10 meters in east direction, this vector on this quadrant system, so I can show it here, I can show it here, I can show it in this quadrant, I can show it in this quadrant. They all represent 10 meters in east direction, because they all are facing in the east direction. So it doesn't matter where you are showing it, you can show it here, you can show it in this quadrant, and any of the quadrant. So same way, this vector, I can show it here also. So now let's get into the details of this. So if this component is mg, and this angle becomes 90 degree, and if this is a 90 degrees angle, and the hypotenuse in this becomes mg, so this component will become mg cos theta if we apply the SOHCAHTOA, and this component will become mg sin theta. So by applying this right angle triangle, I've been able to find out, first of all, this component value. So if I know the mass value, gravity value, we all know 9.81 on Earth's surface, and sin theta, if the angle of the wedge is given to us, we can easily use that. So one of the component of force I've been able to find out. So now mg cos theta, let's concentrate on this one, mg cos theta, which is acting in the downward direction. So the normal force, remember we talked about when the objects were placed on a horizontal surface. If this is a object which is placed on a horizontal surface, and force acting in the downward direction was mg. For Newton's third law says that equal and opposite reaction there is an equal and opposite reaction to the force applied. So in this case, that will be normal force, normal to this surface. That's why this is called normal force, which will be equal to mg. So same concept will apply in this case. So the force acting downward is equal to mg cos theta. This is not the force acting in the downward direction, although this is acting in the downward, but this is not normal to this surface. So that's why I'm trying to take the component of, I'm trying to take this force which is acting normal to the surface. So if this is normal to the surface, opposite to this one will be this is the Fn, and then this will be equal to equal and opposite force. This is mg cos theta. Now according to the Newton's third law, we figured out Fn value, which is equal to mg cos theta. And if I can recall the what we've learned in what we learned when we were talking about the forces acting on a horizontal plane. Same concept we will apply. So if force is applied in the forward direction, this is the force applied, and then there is a opposite force Fn, F force of friction, which acts in the opposite direction. And if I wanted to find this force of friction, the formula for the force of friction is mu times mg, or mu times normal force. I can say mu times normal force. That will give me the magnitude of the force of friction. So mu is the coefficient of friction between these two surfaces, and that depends upon the surface roughness. So same concept we will apply here. If I wanted to find the force of friction between these two surfaces, let me select the color. So I'm gonna change the color here. So let's select this color. So I wanted to find the force of friction. I'm gonna assume that there's a force applied in the forward direction. Someone is applying a force of some x newtons in the forward direction. So force of friction, because I'm applying a force in the forward direction, so force of friction will act in the opposite direction here. So this will become force of friction. And force of friction, we're gonna use the same formula what we've learned when we were writing down the equation for the objects placed on a horizontal surface. So this will be equal to force of friction is equal to mu times Fn, and then this value will be equal to force of friction is equal to mu times mg cos theta. All right. So now we have three things. One is on, now I wanted to solve all the forces which are acting on an inclined plane. That's what we said in this beginning of this video. That's our objective. What are the forces acting along the inclined plane, along these directions? That's what we wanted to resolve, and that's what is of our interest also. Now there are three forces. One is force of friction, which is acting on the inclined plane, which is equal to mu mg cos theta, and then the second force is equal to fg, which is equal to mg sin theta. And I'm not worried about the directions right now, so I'm just writing down the forces. And then the third one is force applied. Okay, now these are the three forces which are acting. Now let's write down in a systematic format. So I will erase this first of all. So I wanted to write down the net equation for the net force acting on the inclined plane. So F net, we've said F net equal to the sum of the rest of the forces. So what are the forces acting on this plane? So F net is equal to one of the force acting in the forward direction. So one is F applied. So I'm going to name it 1, 2, 3. These are the three forces acting. So this is F applied, because it is acting in the forward direction. So I'm going to take it as positive. So anything acting up the inclined plane, I'm going to take it as positive. Down the inclined plane, I'm going to consider it as negative. Down the inclined plane is negative, up the inclined plane positive. So F applied, then mg sin theta. Mg sin theta is fg. Fg is acting. So fg is acting in which direction? This component is acting in the downward direction. So this I'm gonna call it as negative force. And remember this thing, guys, if you're a little confused, fg always acts, this component of the force always acts in the downward direction. So this fg on an inclined plane I'm talking about. I'm not talking about fg equal to mg, because earlier I said that we are only bothered about whatever forces are acting on the inclined plane. So please make sure you're not confusing yourself. So this is equal to fg, which is acting on an inclined plane, and then the third force, which is equal to force of friction. Now I'm going to consider, in this case, because applied force is upward, I'm going to consider it, this is also negative. But I wanted to write a generalized equation. That's of my interest, because in some cases we never know in which direction the object is moving. It may be moving in the down the inclined plane or up the inclined plane. So let's try and figure out the generalized equation. So now I'm going to use this equation and try to write down the generalized equation. So F net, we say F net is equal to what? It is equal to sum of forces, or also equal to MA. So this is one formula for another formula for writing F net also. And then F applied, we again, it is acting, we're gonna assume this is acting in the upward direction. Fg, we've said that this is acting in the downward direction, but force of friction will always depend upon whether the object is trying to move in the upward direction or in the downward direction. So, let's take an example. Let's say this force is 100 Newton. All right, and then this gravitational force comes out to be only 50 Newton, and then force of friction value is also, if I calculate the force of friction, it comes out to be, let's say, 20 Newton. So net force will cause the object to move in the forward direction. So we gonna 100 minus 50 minus 20, that means the object is moving in the upward direction. So in that case, force of friction will be negative. But there will be a scenario in which the object is moving in the downward direction. So if there is no applied force, let's say there is no applied force, so that force of friction, then this gravitational force will try to, this 50 newtons of gravitational force is trying to pull this object in the downward direction, and force of friction will act in which direction? It will start acting in the opposite direction, in this direction. So this keeps on varying depending upon in which direction the object is moving. So I'm going to call it, rather than using only negative sign, I'm going to use a positive and a negative sign for force of friction. So this becomes my generalized equation. So what I want you guys to remember is that the force of friction can be positive or a negative depending upon in which direction the object is moving. If the object is moving downwards, force of friction will be positive because it will act up the inclined plane. And if the object is moving upwards, then it will act down the inclined plane. So now F net, which is MA, equal to F applied. This if I resolve, this is Fg is equal to mg sine theta, and this is plus minus mu mg cos theta. So when I'm going to use this formula, again repeating in this video also, whenever you are given the coefficient of friction or you are asked to find the coefficient of friction, only then you use this formula. This is also force of friction max. So I'm going to write this max also. This is, we are talking about the maximum force of friction. So you will only be using this formula mu mg cos theta when you are given the coefficient of friction or you're asked to find the coefficient of friction. So hopefully you were able to understand about this equation, and this is the generalized equation. You can apply to any force questions and you will be able to come to the conclusion using this equation. So thanks for watching. Have a good day, and in the next video I'll talk about how to use this equation.